Hi, in this video, I will be explaining a medium level binary tree problem in LeetCode, which is maximum difference between node and ancestor. The prerequisites to solve these problems are tree data structure and recursion. Okay, now let's dive into the question. In this problem, they will be giving you the root of a binary tree, and the goal of the problem is to find the absolute maximum difference of any child with its ancestor. Now, we will be looking at an example case. In this tree, looking at the two tree nodes, 8 is will be the value of root node and 10 is the value of its child. And the maximum absolute between these two values is 2. Now, 8 will be considered as the direct parent and also ancestor of the node, which will be holding the value 10. As 8 is the root node, it will be the ancestor of all the values in this tree except itself. Likewise, 3 will be the ancestor of 1, 6, 4, and 7. We need to find the absolute difference between any of this node with its ancestor, and the yielded result must be maximum among all possible absolute difference in this binary tree. Okay, now we dive into the algorithm part. First of all, in this problem, we can see that everyone try to find the answer in brute force way. In brute force way, we will think that use the property of ancestor. Consider the node 8. It is the ancestor of all its child nodes. So we can do the operation. We choose a particular node and we try to visit all its child nodes. For example, if we choose the 8 as the root node, we try to visit all of its child nodes. We 8 and then visit 3. So the difference between this 8 and 3 is 5. And then we go to 1. The difference between 8 and 1 is 7. And then we try to go 6. The difference between 8 and 6 is 2. And the same way we visit all its child nodes. So this can be order of n time for each node. If we then again we will do for 3, we go to 1 and we go to 6 and then we go to 4 and then go to 7. So for each node it can be go up to order of n times. So the total time complexity can be go up to order of n square. It is too large because if we submit this problem then it can be go give us a time limit exceeded. So we want to optimize this approach. So to optimize this, how can we approach that? In most of the problems, if it is a maximize problem or minimize a problem, the approaches can be mostly it can be into two popular algorithms. One is greedy and another one is dynamic program. These problems come under greedy. So let's try to observe more properties in this problem. So the first one is we say that we want to find the absolute difference. So the absolute difference property is the absolute difference always will be maximum if the one of its value is very too far from the first value or too high or can be too low. Or let's consider the 0 and another one is 10. The absolute difference between this value is 10. The same way, if we consider 0 and minus 10, then the absolute difference between those two values can be also be 10. Same way, if we do minus 10 and 0, the absolute always can be 10. So from this approach, we can see that the maximum value can be always get from the maximum child of its node or minimum child nodes. So instead of visiting every node, we just track the maximum and minimum value of child nodes. So let's rewrite this algorithm. Consider node 6. So in node 6, there is two nodes. One is 4 and the 7. So the maximum value of its child nodes are one is 4 and another one is 7. So this two nodes only can give us an answer for 6. So this 6 minus 4 is can be 2 and 6 7 is 1. So these are two possible solutions which can be the maximum value. And then if for node 3, maximum value of its childs except itself is 7 and minimum one is 1. So this can be lead us to the maximum solution. So the difference between 3 and 1 are 2 and the difference between 3 and 7 are 7 minus 3 4. From this 2 value the 4 is the maximum, so this can be the maximum answer. The same way apply for every nodes. For let's consider for 14 the maximum value is 13 and the minimum value is also 13. 14 minus 13 will be is 1. This approach continue up to for each node. Then we will finally while we reach the root node, we calculated the maximum absolute difference value. So this is the concept. So now let's dive into how we can implement this using the code. Okay, now let's move on to the step-by-step procedure. So first we do the DFS in the tree. So we start from 8 and then we move to the 3, and from 3 we move to 1, and from 1 we reach the end of the tree. So we will backtrack. So while we do backtrack, we want to find the maximum and minimum. We want to calculate the maximum and minimum value. So this is the end of the tree. So we want to return minus infinity and plus infinity. So minus infinity for maximum value and plus infinity for minimum value. So it will return minus infinity and plus infinity. If we reach this node, then we will check its child node's maximum and minimum value. The child node's maximum and minimum value is minus infinity and plus infinity. So which indicates there is no child nodes for this. So we cannot find the absolute difference for this node. So then we update the maximum and minimum value with this one. So now the maximum value can be updated to 1 and minimum value is updated to 1. This is updated, sent back to 3. So now 3 has maximum value is 1 and 3 minimum value is 1. Then we will explore its right child, and then we move to 6 and then we move to 4. And 4 is the leaf node. Then the same one is applied, is minus infinity and plus infinity return. It has no, it is a leaf node that so it does not have any it does not we cannot calculate absolute difference for this node. Then we will recalculate the maximum and minimum value. So the maximum value can be 4 and the minimum value can be 4, and we again calculate the right child of 6. Then the maximum value is 7 for this node and the minimum value is 7. Then it will be returned back to this parent. So it's while return back, so we want to find the maximum of both right child and left child. So maximum of this both right child and left child is 7, and the minimum of the both right hand child and left child is 4. So we want to calculate the absolute difference of 7 with 6 and is 4 with 6. So the difference is 7 with 6 is 1. So this can be one of the possible answer, and the difference between 6 and 4 is 2. This can be one of the possible answer. So that we want to choose the maximum one, so we will choose the 2 as the answer. So now the current answer is 2. Then to this minimum value and maximum value sent back to 3. So 7, 4 is sent back to 3. Now again we want to find the maximum value among this left child and right child. So 1 and 7, the maximum value is 7, and the minimum value of its right child and left child are 1 and 4. We want to find the minimum one. So 1, 4 with minimum value is 1. So again we want to check with its we want to find the absolute difference between the maximum value with its current value and minimum value is current value. So it is 7, 3 is 4, and 1 with 3 is 2. So the maximum one is 4. So we will update the answer with 4. So the same approach is handled in throughout the tree. If you simulate this, you will try to simulate with this yourself, and then you can find the approach. So now let's dive into program. Okay, now we see the code. First of all, I use the one helper method, which is DFS, which take root as a parameter, and the return type of this method is pair, because we want to return the minimum and maximum value. And also I use the another variable, which is answer, which is a global variable. Initially it is the integer value. So let's dive into the base case. The base case is if the root is null, which means we reach the end of the tree. If we reach the end of the tree, we want to return the maximum value into max value for its left minimum one, and minimum into min value for maximum one. So this is the base case, and we call the left child for left child and also right child. It is the basic DFS approach for tree. This will give us the maximum and minimum value of its childs, because it recursively call this method and it will return the minimum and maximum value of its child, and also we will do it for right child also. Finally, we combine this both left child's minimum and right child minimum into minimum, and also we combine the both right child minimum and right child maximum and left child maximum with its maximum value. So this is the current minimum and current maximum. If the minimum value is not is int max, then we can find the absolute difference between the ancestor and node, because if to find the absolute difference, we at least need two nodes. If there is only one node which is a leaf node, then we cannot find the um, absolute difference. So this is the one of the case. So that's why I checked whether the minimum is int max or not. If the minimum is not int max, then we travels at least two nodes. So then we update answer equal to maximum of answer with absolute difference between root 12 and the minimum. And also if the maximum is also not int min, then which indicates that we visited two nodes. So then we update the answer with the current answer and the absolute difference of current value with the maximum value we calculated till its subtrees. Then we return the minimum and maximum value of the current nodes. So this current node is updated with the already calculated minimum value and maximum value. Then it will be returned. So this is the code for this. You can also write this code very smaller one if you calculate from the top down approach. I calculated the minimum and maximum value from bottom to top because it will be more understandable. If you can also do from top to bottom approach. Finally, the time complexity of this problem is order of n because we only visit the each node exactly once. And the space complexity will order of height of the given tree if we consider the recursion called stack space, else order of 1. Code link for this problems will be given in the description of this video. This is it for today. Meet back again with an interesting question. Bye.